Hey guys, how's it going? In this video, I'm going to go through this problem from Pramp, award budget cut. So this question was asked in a phone screen interview. Uh, so the original question from Google was salary budget, and this one is a grant budget. It's the same thing actually. Let's go through it together. So the awards community of your alum matter, i.e. the college and university, asked for your assistant with a budget allocation problem that they are facing. Originally, the committee planned to give N research grants this year. However, due to spending cutback, the budget was reduced to a new budget of dollars. Now they need to relocate the grant. The committee make a decision that they would like to impact as few grant recipients as possible by applying a maximum cap on our grants. Every grant initially planned to be higher than cap now will be exactly cap dollars. Grants less or equal to the cap obviously won't be impacted. So we are giving an array, grants array of original grants and reduce the budget, new budget. We need to write a function find grant cap that finds in the most efficient manner a cap such that the least number of recipients is impacted and that the new budget constraint is met. In other words, sum of the n relocated grants equal to the new budget. Also, we need to analyze the time and space complexity. So let's look at a numerical example in here. We are given the grant rate to 150, 120, and 1,000. So the new budget needed is 190, and so the function should output the cap rate should be 47, which will result to the new grant will be 2, and so 47, 47, 47, and 47. So only the ones below 47 is not impacted, and everything be above that, like this 4 grants, will be capped at 47. Okay, and the sum of this array will be exactly 190, which is exactly the new budget needed. Okay, so let's walk through it in the algorithm. First thing first, we need to have to sort it because we want to see we have to find the cap rate that impact the least amount of people, right? So the search for cap rate will be starting from the highest grand number to the lowest grand number, because if we pose a cap the highest grand number, and that will be the least amount of people that we impacted, right? And then we have to lower it down to here, or lower it down to here, and all these people will be impacted, but the people below it. Okay, so that's why we have to search from the highest amount to the lowest amount for the cap rate. And the first thing to do that, we have to sort the array. Okay, so after the sort array, which takes a big over n log n, and the sum of this array, this is the initial sum before imposing any cap, right? So it will be 2 plus 50 plus 100 plus 120 plus 1,000, which is 1,272. And if this number is less than the new budget, and we are done, right? So cap rate will be like the highest number, and then nobody is impacted. In this case, the 1,272 is greater than 190 of the new budget. So right now we will try to narrow it down and then find the cap rates. Okay, and the first cap rate we can try is the highest amount, which is a 1,000, and again, which is greater than the budget. So we keep trying, and now we try the cap rate, which is 120, and also we have the indexing comes along, and the beginning the index is 0, and now we increase the index from 0 to 1, and now the running sum, it is the original sum minus the one that impacted by the cap rate, which is 1,000, plus the new cap rate. Okay, so now we have the old cap rate, which is 1,000, the new cap rate is 120, and then if we do the arithmetic, and now the new running sum is 100, which will be 392, and now this sum is still greater than 190. Okay, and now we continue to try, and the new cap rate will be 100. So the old cap rate is 120, the new cap rate will be 100, and the new running sum will be 392, which is the original running sum, minus 2, which is the index, times the difference between the old cap rate and the new cap. Okay, and then we arrived at 352. In this case, when we have a cap rate of 100, so all this grant will be impacted, will be capped by 100, but the grant is less than 100. So if we sum that, 100 plus 100 plus 100 plus 52 plus 2, which is exactly 352. And this is still greater than the new budget. So we keep trying, right? Keep trying. So now we decrease the cap rate from 100 to 50. So the old cap rate is 100, new cap rate is 50. The running sum right now is 352 minus 3, which comes from the index that we keep in track of, times the difference between the old cap rate and the new cap rate. And now the running sum is 202, and it's still greater than 190, which is close, but it's still greater than that. We are all still over budget. And now we try the last one, which is 2, which is the first guy, the lowest grant. And if we try that, the cap rate will be set the cap rate to be 2, and the running sum will be 202, which is the prior running sum, minus 4, which is the index, times the difference between the old cap rate and the new cap rate, which is 48. And now the running sum is 10, which is 2 times the number of grants, which is 5, which is 10. And now we are below the budget, so we can increase the cap a little bit. So this is the terminal condition, right? So we basically keep trying until the running sum is below the budget. In this case, it is. So we know that in this case, it is the cap rate should be between 2 and 50, right? If in the scenario where if we try everything, but it's still above, if we try all the members, for set the cap rate to be like even the lowest member, and if the running sum is still above the budget, so that will be easy, right? So we just set the cap rate equal to the budget divided by the number of grants, right? In this case, it's a little bit more complicated, where we know that the cap rate should be between 2 and 50. So what we need to do is to find the old running sum, which is 190, minus the 2, and then divide by 4, and then we find this 47. Another way to look at it is like the old cap, which is 50. I think this formula is a bit more straightforward to explain. So this is the cap rate we solved for, right? And we times the grants that being impacted, in this case 4, right? So we know that the cap rate should be between 2 and 50, and in that case, all this grant will be impacted, will be capped at that cap rate we want to solve for. We don't know yet. So we know the amount of grant that will be impacted is 4 in this case. And then, so cap to be solved for times the number of grant being impacted, plus sum of the grants, I call it sum of points, whatever you want to call it, that's not being impacted. In this case, any grant that's below 50 will not be impacted, and that must be equal to the 190 of the budget of 190. And then we just rearrange the terms and solve the cap rate x that we will solve for. In this case, will be 47, and we can, and yeah. So this is basically the algorithm, and as you can see, to do something, keep trying. We can put it in a for loop, and also we can put some if statement to determine when is the terminal condition. And yeah, this is basically the algorithm. And at this point, feel free to pause this video and try yourself. And now I'm gonna walk through the code. So first thing first, we have to sort the array. I put it in the reverse. So after sorting, the first number will be the biggest grand, second biggest, etc. So this is the most time costing step, which is takes big of log big of n log n. And now we have a running sum. I call it a sum. You can call it whatever you want. And just call sum function. Now the first step is 1 to 72, which is exactly what we just discussed right over here. This step. And then next step, if the running sum is below the new budget, we are done, right? So just return the cap rate. Just say whatever cap rate that is above or equal to the highest grant amount, and then we are done. So basically, there's no cap rate needed. Okay, and now we need two variables. One is the old cap rate, which is the previously set cap rate, and the new cap rate, because we need to take the difference and then to determine the running sum. And of course, we can always like reevaluate the running sum by just look at all the elements, but that will be very slow. So to make it faster, we can have two variables, keep track of the difference, and then to times how many variables being impacted. So that will be indexed. I keep track of, right? So the initial index will be 1, and then I added 1 each time, because number of grant will be the number of grant being impacted will be increased by 1 each time. So I have to add it to the index. So for all the grants in the grants array, so starting from the first, the second largest grant, because the first one we have already put it in here already. Okay, so starting from the second largest grant. So currently the grant will be 120, right? The G is 120. If the running sum is greater than budget, right? And this is the condition where we have to keep trying, right? And the new cap is equal to the G, and now G is 120. Okay, so basically first condition is 1 to 72. That's greater than the new budget. Okay, and then we do the following. New cap equal to G, which is 120. Running sum is equal to the prior running sum, and then and then minus the difference, and then times the number of grants to be impacted. So after we do the arithmetic, and the new running sum will be 392. And so now the old cap will become the new, we record the new cap and push it to the old cap, which is 120 in this case, increase the index. And the next iteration, we got 392, which is greater than 190. Okay, and then the new cap will be set to the third largest grant, which is 100. Running sum right now is 392, which is the prior running sum, minus the difference times the difference between the old cap and new cap times the difference times the number of grants being impacted. So the new running sum is 352. So basically this is this step, and that's still greater than 190. So you can see that we just keep trying. We just formulate this algorithm become a for loop until when we get out from this for loop, either we running out of grants being analyzed, or we find that running sum is less than the budget. Okay, if we get out from this for loop due to the fact that we are running out of grant being analyzed, that means that even we set the cap rate at the lowest grant, and that's still not low enough. In that case, it will be easy, right? So the cap rate can be set as the budget, and then minus plus 0.0. I just convert to a floating number, divided by this is the Python 2 thing, right? So this is IDE. That's the problem. I have to convert it to a float, divided by the number of grant, and that will be the cap rate. So this is the case again. This is the case where even we set the grant, set the cap rate at the lowest grant, the smallest amount grant, that's still not low enough, right? And then we just set the cap rate. It will be easy, right? So cap rate will equal to the budget divided by the number of grants. And in the case where we just analyzed, there's somewhere between 2 and 50. In that case, we just apply this formula, right? We solve for this cap rate, okay? And the B sum, basically, we just keep track of and just scan through the grant array again to see how many grant is less than, in this case, less than 50, okay? If that's less than 50, you should add it to the B sum. The reason why I call it B sum is just want to differentiate between B sum and A sum to avoid confusion. So the last step will be take the difference. So basically, take the difference between the budget and the sum of grants is less than 50. So I put it in the other side of the equation. It will be budget minus the sum of grant less than 50, and then divided by in this case is I minus 1. In this case, you can see 5 minus 1. Basically, it's I minus 1 in general. Let's run that, and it passes all the test cases. Again, time complexity with a big O of n log n, which comes from the sorting. And also, it takes a big O of n on the for loop and big O of n in this for loop as well. But the dominating factor is the sorting. Okay, for space complexity is big O of 1. We didn't use any actual array in here. We do the sorting in place. We have one or two actual variables here and there, but this is just B of 1. We didn't have a actual array being to help us. Yeah, so the algorithm and the solution. I hope this is helpful. If it is, please consider like and subscribe. That would be a huge support. And remember, don't trust this. Try yourself. Thank you so much for watching. See you next video.